Yes, welcome everyone. My name is Joshua Oluwafemi Olumoroti. Right now you are watching Seat of Wisdom Tutor. So today we are considered the subject, physics as a subject, and we are taking a look at dimension of units. I get to know that many students don't understand the deep concept of dimension when it comes to physics. That is why many get to find it difficult to know. But I know by the help of today's tutorial, at the end you will know that this thing is just as simple as ABC by the help of God. And if you just pay attention and give me your heart, your body and your eyes, look at it very well. Let your heart be here as you are watching. Don't do any other things and stay focused. So when we're talking about dimension in physics, so we are talking about the three things that are very, very essential. Is this MTL? M, that is mass for kg. T for time, that is seconds. And L, distance, meter is what? Is measured in meter, that is L. So the first thing we have to consider here is work done. And for you to get the dimension of work done, just get to know the formula. The formula of work done equals to what? Force times distance. I'll be splitting this, taking it one after the other. But force equal to MA, that is mass times acceleration. Also, acceleration equal to what? Velocity over time. So you get? I believe that every as a science student, you should get to know the unit of acceleration to be what? Meter per second square. So if you now recap, putting it here, that work done equal to mass times acceleration times distance. Mass, don't forget that mass is what? Is kg. That is kg times acceleration is meter per second square times distance is measured in what? In meter. Do you get it? So kg times ms minus 2 times m. We now have kg m times m square per second square. So just interpret. What do you have as kg? M. What do you have as m square? That is our m. M raised to power 2. And then our seconds, that is time. Seconds, you know seconds, we write t power minus 2. That is the dimension of work done. Another one we have here is what? Acceleration. Without wasting much of our time, you should know that acceleration is what? Meter from here. Meter per second square. Meter is what? L. So we have L here, and per second square is what? T minus 2. This is the dimension of acceleration. Another thing we have is power. Power. Just know the formula. We're talking about power. What is the formula for power? Power is what? Force over what? Is it force times distance or force over? Is it force times distance or force over time or work done over time? So these are the things you get to know. Don't confuse yourself. Don't mix it up. So power is what? Is work done over time. Work done over time. So power equals what? Work done over time. You don't need to just stress yourself. You have know the dimension of work done. Just add time to it. So this time is what? X per second. So if you now increase it from here, that we have kg m2 x minus 2 over what? X minus 1. So from the law of indices, this division will coming up now. From the law of indices, that we have what? Kg m square, x minus 2. So far that this one is what? Sorry, this one is raised to power 1. If it's coming up now, it will change to what? Like let's say dot x minus 1. So now what? Kg m square from the law of indices. From the law of indices, we have the same base. Just take 1. Then we add what? The power together. Minus 2 plus minus is plus times minus, we have what? Minus. That is minus 1. So everything will give us what? Kg m square x x minus 3. M minus 3. So we have what? Kg m squared raised to power minus 3. Raised to power minus 3. So we now have what? If you look at it here, kg is what? Kg is mass. Meter is length. We have L2. And then seconds is what? Minus 3. That is T. You carry what? Minus 3. This is what? This is the dimension of power. So in short, we can say we have got the dimension. So that is why we call the unit of power is what? Joule per seconds. Work done is also measured in joule. So joule per seconds. Another thing we have here is pressure. We have pressure. Let me wipe off this side. Let me clean this side. So pressure. Who can just, I believe you know the formula for pressure. If you know the formula for pressure, pressure is what? Pressure equal to what? Yes. Pressure equal to what? Pressure equal to what? Pressure equal to, is it volume over area or force over area? I believe you guessed right. Yes. Pressure. Pressure is what? Force over area. Force over area. You don't need to cram all these dimensions. What you are expected to do is to know the formula of each unit. By the time you know the formula, or in short, if you know the units of any given question, you will be able to go to solve easily. Either you know the formula to solve the question, or you know the units. So pressure is what? Force over what? Over area. Force over area. Going, you know, force is what? Force is measured in Newton. Area is measured in what? Meter square. So just the Newton per meter square. And Newton is still equivalent to what? Kg m kg, okay, F, I'm coming first times acceleration, that is force, MP, kilogram, meter, pass, okay? Kg m x squared, and then we still have what? M squared, that is times this our m that we have here. Newton at the stand is what? It means kilogram meter per second square. So times our m per m squared now. So we have what? Kg. So m times this, you know this times, so we go to reduce to what? M minus 1 x minus 2. I believe you get how I arrive at minus 1. You still go by the law of indices in mathematics. This m dot m, this one is having 1, this is having minus 2. So why that is multiplication? So it will change to what? To minus 1. So the dimension of this will be what? Kg is m. Meter has reduced to what? To minus what? N minus 1. Then our seconds, we still have what? T minus 2. Get it? Yes. So let's forge ahead. Let's look at velocity. Velocity is just what? The unit of velocity is what? Meter per second. So you don't have to stress yourself on that. Meter is what? Is length. And then per second is what? T minus 1. It's as simple as that. Another one is momentum. Momentum. So momentum is measured in what? Momentum. If you know the unit of momentum or the formula of momentum, momentum is measured as rho equal to mv. That is mass times velocity. Mass is what? Kg. Velocity is what? Meter per seconds. Meter per seconds. That is why the that is why it is get to know that the unit of momentum is Newton seconds. Newton seconds. The unit of what? Of momentum is Newton seconds. So when we have mass, momentum is what? mv. Mass times velocity. So kgm is still what? Kgms. Kg is still what? M. Then our meter is still what? N. And then we have what? Minus 1. That is what? Dimension of momentum. So dimension of impulse. Impulse equal to Ft. So the unit of the formula to get your impulse is what? Force times time. Force times time. Force is what? Is measured in Newton, of which is the same thing as what? Kilogram per meter per second square, then times our time, which is what? Per second. So that means that by the time we go by the law of indices, this we go by kg m s is power minus 1, because these two things have reduced the power to the what? Minus 1. So the unit of impulse we get what? Kg stand for m, sorry, the dimension rather, and then m stand for what? Length, and then our t minus 1, momentum and impulse. Momentum and impulse. Momentum and impulse. This one is not. So another one is density. Yes, density is rho equals what? Mass over volume. Mass over volume. Some will say the unit of density is kilogram per meter cube. Kilogram per meter cube. So just look at it. Kilogram is for what? Capital letter M. Put it there, M. And then meter cube, our length, n minus 3. That is the dimension of density. So of course we have that of force here. Force is measured, the unit of force is Newton, and C equals to what? Kilogram meter per second square. That is equal to F, force equal to MA, mass times acceleration. Mass, kilogram, acceleration meter per second square. So our mass, kg, is m, and then our m, that is L, our seconds, that is t minus 2. T minus 2. So the last one we have here is energy. The formula for energy equals to what? Power over time. Power over time. We have the definition of power here. Don't forget, mf2 t raised to power minus 3. But the unit of energy is called what? It's called joule. It's called joule. So just, the unit of power is what? Joule per second, while the unit of energy is joule. So if you express this, you have what? Joule per second, right? Over seconds. So this one we cancel that. We are left with only joule. And that joule simply means what? Just reduce. As simple as that. Just minus 1 from this one, or remove 1 from this power, is you get what? To 2. So the dimension of energy will reduce to m to c raised to power minus 2. This is what? The dimension of energy. If you look at energy and work done, it's almost the same thing. This will be the end of today's tutorial. I believe that with the help of God and this little explanation of mine, you have learned 1 or 2 things. Just go over it again, try the method I give to you, and then you see that you are moving forward. So please don't forget to share, like, watch, and comment. God bless you, everyone. Bye for now.